This video is on the objective calculate and interpret the confidence interval for a population proportion. And this is number 1, right? So the first video on a question from your Newton Alta homework related to this particular objective. Alright, so again, if you're unfamiliar with the topic, you'd like to see some more about it, more instruction, just click on more instruction here. See what they have to say, what kind of videos or notes they're throwing at you. Look at their examples, hopefully it helps. And of course, I'm hoping you also read section 8.3 of your OpenStax statistics book. May also help. Alright, so here, I'll just read through the question and show you how to perform what we need to perform. So Emma wants to estimate the percentage of people who use public transportation in a city. She surveys 140 individuals and finds that 62 of them use public transportation. So we're asked to find the confidence interval for the population proportion with a 99% confidence level. All right. So her population here is the entire city, all right, the people in this entire city. And the sample she took, was 140 people from the city. All right, so let me go and write out what this scenario looks like. All right, so for this particular problem, a success, what we're deeming to be a success here is if the person uses public transportation. Okay. Now we have this population of a city, of some city that Emma lives in, and remember lowercase p just on its own with no hat or apostrophe, just lowercase p on its own represents the proportion of the entire city, right? The proportion of the population that uses public transportation. And we're trying to guess what this is with an interval, right? We're going to guess that the value of p is somewhere in this range, right? Somewhere in some interval range. Okay. So again, this is unknown. Now, from this population, a sample is taken. A sample of, n equals, now she said that there is 140 individuals. And remember, we're letting x represent the number of successes. So x represents, the number of individuals in this sample that use public transportation, and that was said to be 62. 62 of these 140 people used public transportation. So for this sample, the sample proportion, the p hat, is 62 out of 140, which I'll approximate. When I go to the calculator later, though, I'll probably just enter 62 out of 140. But let me pull the calculator up, and 62 out of the 140. That is about 44%. I'll go approximately 0.442857. I'm not going to type all that in later, but 442857, right? So a little more than 44% of the sample used public transportation. All right, so now, remember the central limit theorem for proportions. Now, if we were to look at all possible samples of size 140, all right, if you were to look at all possible samples of size 140, and also because 140 times this is greater than 10, and 140 times 1 minus this is greater than 10, we can apply the central limit theorem, but you're not going to have to worry about that too much. So again, if we were to look at all possible samples of size 140 and look at the p-hats, the sample proportions for all of them, those sample proportions, those p-hats, would have an approximately normal distribution with a mean called, mu p-hat, and the standard deviation of all these p-hats, sigma p-hat. Where the mean of these sample proportions, remember that was equal to the population proportion. But I don't know what this is. We're trying to guess this. So what we do is we use our point estimate. Right? We use our sample proportion here. I'm going to use 62 out of 140, right? This 0.44 something as a point estimate. All right, so I'm going to have p hat be the mean now. This is 62 out of 140. And the standard error or the standard deviation for these p hats, for all the p hats for samples of size 140, remember that was the square root of p times 1 minus p divided by n, right? The sample size. But again, I don't know what p is. So we're going to approximate it using our p hat again, using our point estimate. So this is the square root of p, 62 out of 140, times 1 minus p would be the other 78 out of 140, right? Because 62 plus 78 makes 140. Then divided by the sample size 140. Right? All that inside the square root. All right. And I'll punch this in. All right, so let me go back, bring the calculator up. Now, this value I just had here, this is our p hat, right? This is our point estimate, 0.442857, right? So I'm just going to leave this the way it is, and we'll go square root of the previous answer, right, that number, times, and then in parentheses, 1 minus that previous answer, and then divided by 140. Right, and again, make sure all of that is under the square root. So here's our standard error for the proportions, the sample proportions. It's 0.04198. Right. Okay. Now I'm going to just on the calculator, because I know I'm going to be using this number again later. I'm going to be storing this number as the letter X, so I'm hitting stow and then X and then enter, and then now every time I use the letter X, it's that number. It's that standard deviation for the proportions. Right. Okay, and then I'm going to draw a picture of a normal distribution. Right, so we have the the distribution of all these p hats for samples of size 140 is normal. So here's a number line representing all possible values of p hat for samples of size 140. We know it's a normal distribution, so I'm going to draw this symmetrical bell-shaped curve. I'm trying my best. It's not perfectly symmetrical, but it should be. Then under the peak, remember under the peak on the number line here is our mean value, which normally would be whatever p is, but we don't know what p is, so I'm using this 0.44. I'm using this 62 out of 140 value in the middle. Right. Now, we are asked to create a 99% confidence interval. Right. So our confidence level is 99%. So what that means is we're looking for these values. So from the middle, right, from 0.44 here, the p hat, my point estimate. Remember, we're going to add a margin of error. So over here is 0.44 plus ME, right, margin of error. And then also subtract that same margin of error, right? So this value on the number line is 0.44 minus the margin of error. And I'm trying to find what these values are so that the area underneath the curve between them is my confidence level. I have 99% of the area there. All right. Now, in order to figure out this margin of error, right, this distance here is the margin of error. This distance here is the margin of error. In order to figure out the margin of error, I need a z-score, right? This is a normal distribution, right? Not one of those students' t distributions, like when you were estimating a mean and had sigma unknown, right? The population standard deviation was unknown. Here we're dealing with an actual normal distribution. So it's going to involve z-scores. And to figure out how far this is away, this upper value, and this lower value, how far apart they are from the middle, I need a z-score. And you're going to notice that this margin of error formula looks very, very similar to the margin of error formula when you were estimating a mean instead of estimating a proportion. It's what z-score has that area of alpha over 2, right? There's that alpha over 2 again coming back, times the standard deviation of, in this case it's the p hats, right? The p hat distribution, the distribution of the sample proportions. Before it was the sigma x bar, right? It was the standard deviation of the x bars, and we know this formula. All right, this is what z-score has an area of alpha over 2 above it, times, and then this standard deviation of the p hats is estimated by p hat times 1 minus p hat, right? Because again, I don't know p, we're estimating it with p hat divided by n. So here is the formula in general for our margin of error that we're going to need to be able to figure out what the lower value and upper value of the confidence interval are. All right, so first, now I know the p hat. I know this standard deviation, right? That was this 0.04198 something. That's this guy in the parentheses here. I need this z-score. How many standard deviations above and below the mean do I need to go to get this 99% confidence interval? All right, now if we're talking 99% confidence, that means that the value of alpha, remember alpha is just what's left over. Alpha is 1% then, or 0.01. So this white space over here above the upper value, along with the white space below the lower value, is 1%. Well, notice that's cut in half, so we got to cut this in half. What's alpha over 2? And that's why this alpha over 2 is here. That's 0.5%, or in decimal, 0.005. So we're looking for this particular z-score. What's the z-score with an area of 0.005 above it, right? An area of 0.5%. Right, above it. I'm looking for the z-score of this particular value. And you can go to a table, you can go to a calculator. I'll show you both. All right, so on the website, see they gave me a little chart here with all these nice critical special z-scores. And we're looking for the z-score that has 0.5% above it, that z with a subscript of 0.005. That's 2.576. 2.576. So I'll write that here. And all this means is that this upper value of the confidence interval is 2.576 standard deviations, 2.576 of these above the mean. And this lower value of the confidence interval is 2.576 standard deviations below the mean. All right, now another way I could have done this was using the calculator. And if I want to find a certain z-score, I can go to that inverse norm. Go second, distributions above the variables button. Down to number 3, inverse norm. And then they say, hey, what's the area to the, now remember this area is the area to the left. So if I'm looking for the z-score with an area of 0.5% to the right, well, if you have 0.5% to the right, that means you have 99.5% to the left. So I'll be entering 0.995 here. And then it's, it's a z-score. We're talking standard normal, right? So mean is 0, standard deviation is 1. And if you have an older calculator, you can just enter the 0.995 and close the parentheses. Just enter the area to the left, and it'll automatically assume the mean is 0 and standard deviation is 1. And you see the 2.5758, that's rounded to 3 decimal places. That is 2.576. That is the z-score of this upper value and lower value. That's how many standard deviations away from the middle those upper and lower values of the confidence interval are. All right, so you could have found it with the calculator as well in that inverse norm. All right, but we were given a chart. All right, so now that I have this and I know my standard deviation, then the margin of error in our confidence interval is 2.576 times, and then this standard deviation of the p-hats, this square root of p-hat times 1 minus p-hat over n, we already found, is about 0.04198. All right. 0.04198. So, and rounding to 3 decimal places. 3 decimal places they wanted. So I'll just take this, I'll take the number they gave me, 2.576, and multiply it by, remember I called it x, right? This 0.04, that was the standard deviation of the p-hats. And there's your margin of error, 0.108 if I go to 3 decimal places. All right, so there's the margin of error. Meaning that this value here is 0.44 plus 0.108. And this value here, the lower value in the confidence interval, is 0.44 minus 0.108. So I'll enter this in my calculator as well. Now I'm just going to enter the fraction. All right, I'm going to use the p-hat. P-hat was 62 out of 140. Actually, you know what? I'm going to take this margin of error and store that as x now. So now x represents the margin of error. All right, so let's take 62 out of 140. That was our p-hat, and then minus x. And here's the low end, the low value of our confidence interval. All right, so our 99% confidence interval starts off with, so 99% confidence interval CI for P, right? We're using this to estimate P, the population proportion. The low end is at 0. To 3 decimal places would be 335. And then the high end, I'm going to take, I'll just take this, do the same entry, just change the minus to a plus. And it's 0.551 if I round to 3 decimal places. All right, so what this means, is that we are, given this sample, given this information that we were given about these people that take public transportation, we'd be 99% confident that the percentage of the whole city, the whole population that takes public transportation is somewhere between 33.5% and 55.1%. So that's what that means. So let me enter these down here. Right, so to 3 decimal places, round the final answer to 3 decimal places. The low end was 0.335. The high end 0.551, and hopefully I'm not off by 1,000th or something. Fantastic. Right. Again, read through the answer explanations, please, whether you're right or wrong, especially if you're wrong, though. Right? And look at, see the margin of error. They give you that margin of error calculation again. And then you take your point estimate minus the margin of error, point estimate plus the margin of error for your confidence interval, and the finding of that value of alpha and all this, right? So yeah, great. So yeah, we estimate with 99% confidence that the true population proportion of people in the city who use public transportation is between those two values that we said. Great. All right, so again, hopefully this video is pretty long. The next one won't be as long because hopefully you've watched this one, and I'm going to go through the same steps. I'm just going to use the formulas next time and not draw as many pictures. And hopefully this helps you out when you're working on these kinds of problems for this objective on your own. And thank you very much for watching.